Thank you. Good morning, everyone. Today the topic is going to be regarding DeltaV Virtualization using VLANs at Shire Covington. It's a project where I've been working for the last five years. So, always is important, the disclaimers. Information provided on this presentation is most likely based in our experience and knowledge and not something that has come officially from Emerson. I have another personal disclaimer. English is my second language. I'm originally from Puerto Rico, which is a country that's been in the news for the last days. And I mean, so any word that you hear that it sounds like Spanglish, I open for question and for clarification. Yeah. So yes, I've been 15. I have around 15 years of experience on the industry, and
I'm George Goodyear. I've been with CSI for 5 years, but I was in startup and turnover for 5 years before that, and it largely applies, even though it was in a different industry.
Yeah. So the project in Shire Covington is a greenfield facility located on the east of Covington, Georgia, about 40 minutes from Atlanta, approximately 40 miles. We are a company that are dedicated to the immunodeficiency products on plasma donation. Our main products, the products that we manufacture in our sites are immunoglobulin and albumin. So we are a 1 million square feet facility with a total of 16,000 IOs, which we will be covering all the design regarding virtualization about this big site. So today's agenda is going to be focused on virtualized DeltaV, networking basics, planning and negotiation with a stakeholder, optimization of VLAN for our system, key to our success, business result achieved, summary and reference and additional information.
Okay. So we wanted to do a little just preface of some terms that might not be, we have differing levels of skills. Obviously, we're talking about VLANs, which is like a local area network, except there's a tag on the packet, so it's really all on one wire instead of having a separate wire for every local area network. You got a host server. That's going to be the powerful computer that runs several images called virtual machines within it, so that you can basically separate the software and the hardware. And a cluster is a group of these hosts. It could be it could be as many as technically allowed. We'd also like to cover some networking. In the old days, all you had was a hub, and it would multicast and talk to everybody. So if you had a message for host 1, it got host 2 and everybody that was caring to listen. Switch improved on that. It knows who's connected to what port on the switch via the physical address of the card. So it knows that this port 3 is going to go to host 1, and it properly directs the traffic. But the very first time, you're still telling everybody where you are, and you're building your spanning tree. So if you're old enough to remember network storms, spanning tree is not infallible. It's a lot better than it was, though. The thing that we're going to be talking about is a really fancy switch that has a lot of names. It's called an appliance, it's called a router, it's called a firewall. Basically, it's a multi-purpose computer that also has switching functions. The difference is, for our purposes, this is the thing that will add that tag and then collect all this traffic and funnel it into one. So it does all the switch stuff, but it also ensures the integrity of your entire data pipeline. So anybody who doesn't have the right tag can't read your data. It just doesn't let it go to those other ports. So The last basic section is on virtualization itself. So this is a basic representation where several machines are split between two hosts. And let's say your Pro Plus has Windows crash. It's like a blue screen. It's gone. It will restart on the other box. It's not necessarily going to move instantly, but there are high availability situations where you can have instant move over. But if it crashed to begin with, you're going to want to restart it. So in our case, typically we'd just start the box on the other machine. You don't lose any functionality. You can figure out what's wrong with the original VM and fix it. But now we cover the case of a host failure. Now, your host is going to be running various machines. In this case, you got your Pro Plus on one side, you got your batch executive on the other. If you lose that host, you can't bring everything over to the other box. You've only got 4 slots. So you got to pick and choose. You got to know your priorities. And it begs the case of, well, what happens to all the other boxes that didn't fail over? Well, they're not running, just like if the hardware failed. So that is a case. And what if you lose both of them? Well, that's called a cluster failure. So the idea of the cluster is you take these groups of hosts and you distribute the various virtual machines between them so that you have a minimum operating capacity that satisfies your process. So you'd always have a batch executive, you always have a Pro Plus, you'd always have at least a certain number of operator stations, even if you lose a whole cluster. You'd have enough capacity between the two to spread it out. It might be spread thin, but typically the idea is that you would be able to retain full functionality. Oops. The way we have it, we have 2 separate DeltaV systems, and we've built it such that we can lose 2 clusters and still maintain full operational capacity. There's a lot of optimization. You can spend $1 billion just on how much redundancy you want. So the key to our success was planning. We had a lot of variables that went into this. The first questions regarded the actual physical design of the system. Is a vertex better? Is a SAN better? How do you distribute the hosts? How many hosts do you need to run all of the machines that we need? Early on, it was determined that a lot of the pain involved in this project was going to be related to operator stations because we had a lot of them. And that begged the question that, how else can we save? Well, maybe we can save on networking. So stepping back a moment to the system design, how is a virtual system different than a normal DeltaV system? You might not necessarily know what you're going to call everything when you start designing a DeltaV system. You know you have a Pro Plus, you know you have an app station. But if you want to wind up with a virtual system that's great, these are the things that you absolutely have to have going in before you even start planning. You got to know what you're going to name everything. You got to know IP addresses. You got to know cluster names, IP addresses for the cluster, all these technical details that we wouldn't necessarily think about during a physical design. And then we get into how much money are you willing to pay? All 3 things of these, they mean you need more hosts. And you can add redundancy until you're never going to go down. You're going to have 6 decimal places of 9s, but you're going to be paying a lot of money for offsite hosting and fast servers and basically a lot of extra capacity that you're not using day to day. The other things that you need to consider when you're building the system is, what if you lose a control room and it burns down? Where are you storing your data? Are you backing it up regularly? For pharma, this is a business principle. You can't lose data. So that was also a consideration.
Go back one.
Go back? Okay.
Next.
Oh.
Next, yeah. Okay, so the system design and selection in our project started from the very early. At the moment that we did our selection for virtualization, the Vortex solution were not available yet, so we decided to we choose to have Sun with a host server, and even though Vortex saved space, it was a new project, so space was a not critical issue for us, and we have for our side, the system requirement was to have 2 full DeltaV systems with a total of 17 host servers and 60 VMs. The virtual machines are split into 2, 25 for one system and 35 for the other system, for a total of 73 controllers. Most of them are redundant controllers. Also, we have 2 development systems with a total of 20 VMs and 20 controllers and 20 virtualized S controllers. We do also have 2 other additional systems for training purpose, which are administered by another department. But that's in a nutshell. Summary of what are the system requirements for our site. So network planning. So the network planning, as I mentioned, and start very early in the project. We have the advantage that we were designing with the IT department together. It was a greenfield facility. We don't need to add a new system to an existing facility where all the IT infrastructure was in place already. So we, in some way, capitalize on the IT infrastructure. And we designed with them using the fiber backbone, which we're going to run all the business network and the manufacturing network together. We plan for disaster recovery, having primary and secondary cluster, and the usual fail-safes for failover, UPS, and redundant cooling. So here is the diagram of what we call the unitized cable. This is the backbone cable that runs for every main distribution facility room, or MDF, to every intermediate distribution facility room where the servers are located and the switches as well. So it contains 96 fiber optic strands, which from those 96 fiber optic strands, we have a total of 16 fiber optic for our system. We have 2 DeltaV systems. We have virtualization, which that include that in addition to having primary and secondary network, we have the high availability or cluster management network. We have a dedicated batch executive redundant network, and all of those networks, are going to be connected through this fiber optic strand from point E to point B. So this is an actual picture of our site, which we wanted to show a little bit on perspective, the size of our project and how it was planned in terms of network infrastructure. This here are the 3 manufacturing buildings. This is the administration building. So I want to stop for 1 minute here to give us summary of how we design our network infrastructure. So we have an MDF located on this administrative building, which is represented here. We have another MDF located in this other building, in the fractionation building. This building also have an IDF where we have the PCS / DeltaV servers located. So each manufacturing building have their own cluster for their specific server. But for redundancy purpose, we decided that our secondary DeltaV network is going to be landing here on the fractionation building. Our primary control network will be landing on the administrative building. So if for some reason we lost fractionation building, MDF, we have the primary network running and vice versa.
So like maybe on the last slide you thought, hey, it's not very redundant if you're running everything down the same cable. Obviously, that's a concern. The star mesh takes a lot of that concern out because you'd have to lose 2 of those big cables that are basically the same ones they use for undersea running between land masses. So it's a very strong cable to begin with. But basically, the network traffic would be able to get there, I mean, unless there's some sort of terrible disaster, in which case you've got bigger problems than keeping your system running. Because that cable carries everything, it's all your networks, it's everything. So basically, if you lose that cable, it's a major problem, and they knew that from the beginning. But with the size of the facility involved, there wasn't a whole lot of options other than fiber networking. And bundling those fibers saved a ton of money in wiring and cable trays.
One additional thing that is not in the presentation, but it came to to my mind now, is like we asked IT to provide us single mode fiber optic. Because if we choose multi-mode, then we need to start with the exercise of measure of distance. And that's going to be huge.
Yeah.
So we decided for single mode when we ensure that we are going to be designing for the distance that we need.
Yeah. This main hallway right here is about a quarter mile. This is the parking lot down here. I mean, so it's a very large facility, and obviously it comes with all the problems that you have when your I/O and your networks are widely distributed. But at the same time, it's nice because if you have a problem in one building, it's actually pretty far away. So you don't necessarily have problems everywhere. So related to this, we have 128 operator stations. That's a lot of operator stations. So we had a lot of things to consider with that regarding licensing, also with network runs to those. So we went with Field Bus and DeviceNet. So this is old news, but when we were planning it, it was version 11, and then they switched to version 12, and we saved actually a lot of money on the version 12 licensing update. About 8,000 DSTs we didn't need to purchase because it was the buy one, get 15 free. We are a very large system, and there's a whole bunch of hardware. So part of the planning was who buys the hardware. Working with IT, they were supplying all of the switches and the wires and stuff. It took a lot of the cost center that we would have had to duplicate between process and basically everybody else, and we merged those and then used their purchasing department to get better deals on the hardware, and everybody was happy. I mean, the downside would be basically if you can't work with IT. I know that that's not a usual thing where IT and process get along really well. So I know it's not the usual thing, but I know, but sometimes you luck out, though. All right. So we did also consider, hey, it's virtual. Why can't we run 128 virtual machines? Well, we'd have to add about 6 hosts. So we decided we have a lot of operator stations. They're going to be lightly used, probably just 1 session out of every 6. We went with the terminal server, so if it gets bad, we can utilize all of them. But in general, it's a light loading. We can get away with spreading it thin. And we ended up with about 15 to 18 terminal servers per system. And that's really not bad. I mean, if you've ever had to spec this stuff out, that's not a lot for that many users. We also moved, we showed you the diagram of the clusters where everything's sort of widely distributed. It's not like 1, 2, 3, 4, and all of those ones are in the same room. You want to kind of spread it out so that if you lose one terminal server, it's no big deal. You might lose 1 operator station out of the 8 in the room. But if you lose the whole server room, maybe you don't want any room in the building to lose all of their operator stations because they still have to run the process. So in general, that was also a consideration, spreading that out, redundancy, and what's the worst case scenario for losing everything and keeping going. Also, if you had a shared system, we share between albumin and IG, you only get one batch executive by default per RTS. So you can't split one between IG and albumin because the operators can't choose which batch executive they want to use. Also, it's a pain to get 6 people off of a server if you need to restart it. So here's a typical DeltaV networking diagram. You've got, in general, 8 connections that are typical. And down here, you have your cluster management, which typically only happens between the hosts. You got your thin clients. Those would only go between the thin clients and anybody that's hosting a thin client. You got your DeltaV secondary and primary, which everybody should be familiar with. And we got your plant LAN. In our case, we call that the manufacturing network. And then the batch executive. It could be virtual, it could be real, but typically only batch executives are going to be connected to that for obvious reasons. We looked at these 2 networks in particular because we have so many operator stations, so widely distributed, and also the redundancy isn't as much of a concern with the number of operator stations we have. So we went with simplex. That's reducing one network right there. And then we merged the thin client onto the plant LAN using VLANs. So we figured that the thin clients are already outside of the process network anyways. The thin client network would cross that boundary to begin with. Why not VLAN all of the traffic along one cable? Now you're down to one connection for an OIT. That's one wire run, one network to worry about, one switch. There was a lot of hand clapping and celebration upon figuring that out. So you might say, okay, VLANs, what's the big deal? That's basically what subnets do. If you have a subnet 1 and you have a subnet 2 and you have a subnet 3, you can put all that traffic on one cable, no big deal. Well, the other guy at the other end has to figure out where that traffic's coming from, and there's a little bit of processing that's involved with that when you get traffic that's not intended for you. So you're saving computational cycles by tagging the traffic so that both sides know who they are, and they only have to listen for that one little tag. Then they can start processing the data. But you still need a router. You still need to tell who everybody is. You have to sort the traffic, basically. So there's a lot of ways to do this. And we chose not to tag the traffic at the host level because there's a lot more configuration involved. Additionally, we weren't going to be managing the switches or the routers in the system. So we chose to do that at the switch level because basically this is a commodity technology that can take place at almost any level of the process. The general idea is you could set up in Hyper-V to tag the traffic with, hey, I'm a thin client, and then dump that directly onto the network, and you'd be fine. But you'd have to go into all of those VMs and set that stuff up. It's easier to take all the subnet traffic and deal with it in the server room before you get out into the plant at large, in our case. And then we just have a gateway set up to direct that traffic to the proper place. If you're familiar with your OSI chart, subnet traffic is here in purple. That's layer 3. That's happening in software. Layer 2 is happening in hardware. So, obviously you can virtualize that level 2 up to level 3, and anybody can do VLANs. But that's software, and you're not saving a whole lot of processor cycles if you're taking hardware traffic and turning it into software traffic. So if you do this in hardware, you're going to save time, you're going to save traffic, you're going to spend a little more money because you're buying a fancier switch. But the great thing is IT had already bought all these, so we didn't have to buy them.
So yes, In our project, we take advantage of the bulk part pricing that IT was able to obtain, and we pretty much capitalize on that by connecting all plan-land connection from our servers directly to the IT network. Which from the IT network, they assign a VLAN to each DeltaV system, and from that VLAN, we communicate to the system outside the DeltaV system. This is a representation of our virtualized network. We have here the primary PCS network, the secondary network here.
You'll be familiar with all this.
And yeah, you are familiar with all the technologies that we are using. And here, so from here, you can see the host server have a direct connection to the IT manufacturing network switches. And from this switch, we communicate to all the systems that in some way interface with the DeltaV PCS system or support the PCS system in some way. So there's a dedicated VLAN for thin client OIT connection. So instead of having, as George mentioned, 125 workstation connected to the primary and secondary network of the DeltaV system, created in our database, we choose to have thin clients connecting outside from the DeltaV system using the manufacturing network and having a specific VLAN.
If you want to note, below this dotted line, it's basically just a DeltaV system. There's nothing wacky going on down here. This is just, it's a virtualized DeltaV system as you'd see anywhere else.
Yeah.
Moving on, this is the same dotted line, by the way.
Yeah, so this is a summary of most of the things that we have talked in the presentation so far. This is, I created this diagram because at the point that we start talking about, hey, how we're going to design our system to interface with maybe 7, 8 systems outside the DeltaV system. So then I start working together with IT to see what's the best strategy to do that. So we agree that, as I mentioned previously, we are going to have one VLAN per DeltaV system.
So like see that 100 right there, it's going up, but that's the one that connects to our system 1.
So we have here a representation of all our DeltaV servers. All of them are virtual servers. Then each plan-LAN connection have an IP address on this VLAN. The one for the fractionation system, and the one for the other system, the IG albumin system. So important to say is that we are not using VLAN for process control.
Yeah.
We keep the always typical Emerson recommended design. And all decision that we have in our project was working with the Emerson Technology Group and our IT department together. We have multiple meetings together to ensure that we follow the requirements of our project, and at the same time, we follow also the Emerson recommendation. So, as you can see, every pipe here is representing a VLAN. So, every system have their own VLAN. So, we have our PI system, which is our data historian system. We have also the EVM system, which is our MES system that interface with our DeltaV system a lot. Also, we have the BAS system. We have some OPC data that interface with us as well, and the thin client VLAN. So we have a total of approximately seven VLANs, or which represent 7 different systems, which interface with the PCS system just by that one plan-LAN connection, which is connected to the manufacturing network IT switches, which have one VLAN assigned. In that way, we have a big saving of networking devices.
Can I talk about this?
So yeah, this These systems are here, a total of approximately this and blue and these two here, a total of 6. Were those systems that we save a lot of money by using the IT manufacturing network switches. Because if not, we are going to invest in our dedicated switches and network design just to interface with them. So this is a rough estimate of how much we save, but this is very conservative.
Yeah.
We are sure that we go deep, the saving is going to be more significant. So,
you want to back up, or do you want
yeah.
to? Okay. So, yeah, basically, if you earlier, the blue and the purple, basically the last point in that diagram was the round switches here, and then this is the router that they would connect to on the plant LAN, and that's handing out the traffic. The VLAN IDs are going to exist pretty much from gateway to gateway.
Yeah. So, something that we need to mention. So the traffic of the data, how it works. Every host server has a physical connection to the IT switch, which the virtual machine inside the host server have an IP address assigned to that network. From the manufacturing network switch, then there is a connection, there is a network address there's assigned to that system. Let's see here, we have the PCS system 1 VLAN, so we have a range of IP address like a subnet assigned to the PCS system 1 VLAN. And when data need to come from the PCS system, let's say to our MES system, so is the firewall/router, which is the one that take data from VLAN X and transport that data to VLAN Y. So that's not handled by the switch, it's handled directly by the firewall, which have also router capabilities. Another thing that I want to point is that this diagram here that you can see below.
Let me zoom in.
So we have a lot of PLC package equipment or OEM equipment that run on PLC. We got to a point in our project that we needed to decide how we are going to interface with those OEMs. So in some projects, you will see people that they choose to migrate from the PLC configuration to the DeltaV, which is something that most of the vendors doesn't support. They say this is my design. If you decide to migrate to something different, I'm not going to support it anymore. Right. So, and it's a challenge. So in our case, we decide to interface with them, and we have two options. We have a dedicated network for interface between the beam cards in our DeltaV controllers, or we also capitalize on the IT manufacturing network. So
we have a lot of flexibility in dealing with the PLCs and their individual foibles.
So yeah, we decided to have a direct connection for each PLCs to a VLAN, and have a dedicated VLAN, which we call PLC to PCS VLAN, which every beam card have a connection to that VLAN and every PLC that communicate. And in that way, we were able to save a lot of money because we were very close to start redesigning panels to accommodate switches for communication with the PLC, and in this decision, it was a big cost saving as well.
Okay, so that begs the question, what are they not for? They sound great. Well, this is the Emerson reasoning. Obviously, if you're not redundant if you're putting it on the same cable. So don't let it mess with your ACN. Obviously, the VLAN is not simple technology. It's going to have a little bit of overhead, and in that case, you're either paying in slowing down your switch, or you're paying more money up front for better hardware. It also can lead to, hey, I don't want to buy any more hardware. That was so expensive. Let's just add one more network to that VLAN. We're going to expand. We can fit a few more. And eventually, you will hit the throughput limit of your switch, and you'll saturate. And now you're not saving anything because the switch takes extra time to process. Things will get there late. Additionally, VLANs aren't, easy. I mean, it's not that weird. But at the same time, who in the process department has the extra time to go and fix it 24/7 when some switch goes down and they don't know what's going on and the error message are really esoteric? You got to patch it. There's regular updates, and you'll see a lot of cybersecurity warnings come up for Cisco and things like that, and you have to maintain it. So who's going to do that? In our case, we're really lucky because IT works with us. They understand that the manufacturing is part of the business, and if we can't do that, we're not making any product. So to them, process is just as important as somebody who can't present in their conference room. So if we call in, we'll get priority, assuming availability, and we have a dedicated on-site staff, the 24-hour coverage. It's not necessarily the answer for somebody who has a plant and they're running it basically all by themselves. You might be able to set it up, but what happens in 2 or 3 years when you've forgotten everything you did? So, there's options, and I would encourage you to try to work on the relationships with IT and work with them, because they're the ones in the trenches with this stuff, and to them it's no big deal. It's like going out and learning a new skill. That's their job. They either like it or they don't, but typically they like to do their job. I haven't run into that many IT people who are still in the business at our level and don't like anything. So in typical, those are the low-level guys. We did accept some compromises to do this. We saved a lot of money, but what did we pay for? We have redundant cables. What happens if the switch goes down, where those two cables come together? They have to join at some point. I'm sure you can do redundant switching and all that kind of stuff, but that's not something that they were willing to pay for. That's a lot of extra 10 gigabit switches. We basically mitigated the risk. There's a lot of IT support. There's physical distribution. People get yelled at if they unplug things. That's really all you can do. We did accept reduced redundancy for thin clients. But we have a lot of them, and I haven't heard anybody complain that my favorite OIT is broken. There's just likely to be 1 or 2 working. It might not be ideal, but in general, when you're in a bunny suit in the clean room, there's a lot of things that aren't ideal, and they just deal with it. It's also complicated. Basically, I wouldn't want to learn all the stuff it takes to run our system, but I would if I had to. We're lucky that I can focus on process, and they can focus on IT, and everybody gets their job done. So where did we go with this? No startup delays for asterisks, just for PCS. Can't guarantee results for everyone. We saved capital, we saved labor, we save on every day. If for some reason a cable goes bad or a switch port doesn't work or whatever, you can move to a different one. There's a lot of flexibility. It's very analogous to virtualizing servers. If your server's having problems, you move to a different server. If you need to service that server room, you got to take the power down. You move your virtual machines out of that room. We have switches. We can redirect traffic. It's very flexible. You might have to have somebody walk out to the room and start unplugging cables and moving them around. But compared to a shutdown, that's small potatoes. So, in summary, planning. There's no secret sauce. We're saving money, but we're adding complexity. We saved a lot of money in our case because it's a big installation with a lot of complexity, and that was appreciated so that money could be spent by other people. Are there any questions or anywhere you want to back up to? Yeah?
Yes, sir.
Mhm. Sure. Hmm. Mhm. Yeah. Mhm. Right. Right. And yeah. Yep.
Let me answer that one.
Oh, right. Right. It's not necessarily any easier, but it is a little easier for the guy setting it up the first time. So, I mean, that might have been the preference. At Control Southern, we've been dealing with that since the beginning of virtualization. We've had a few things where we've worked on it before it was, an Emerson approved project, and sort of flying blind. So in general, we've developed our own tools, and it may vary by LVP on deployment and things like that. But actually, I have talked to some of the vendors out here, like P&F and them. They recognize those issues too, and they're through the magic of competition, trying to make life easier for people who use thin clients. So, maybe, I don't know what time period you did your project in, last year? Yeah, so we've seen actually a lot of new products come out like just recently, even with the Dell like hardened workstations and things like that. Before, I mean, you're right, it was really just sort of like, here's some stuff, yeah, give it to your IT department and figure it out. Yeah, and that wasn't available really until your time period. We also dealt with that. But in general, yeah, it's just one of those gray areas where it's going to depend on your local business partner. Yeah. Sure. Right. And deployment is deployment is always definitely one of the big areas that can be targeted for ease improvements, because you're totally right. It's not just plug it in and go. It's not going to figure out who it is. Ideally, you'd have a DHCP server. You'd be issuing all this stuff automatically. All you'd have to do is name the box. You'd have scripts to deploy images, all that kind of stuff. But in general, we don't have time to do that. And we're only going to touch it twice, once when you set it up and once when it breaks.
So something I want to add. I mean, when I started my project, on the project that I'm working on, I took a lot of the decision. I became the key person on my department about taking decision with IT about our design. And sometimes I hesitate a little bit about the decision that we made. But right now, at present, that we are in a stage of our project where we are running what we call conformance lots, which are the batch product which we need to submit to the FDA for approval. Having taken the decision that we took about designing the way that we did is saving us a lot of time too. Yeah. So we can be focused on process automation, which is what really do. If we decided in a different way, having a lot of workstation in our database, use VLANs,
right.
Then
if we had to validate 128 workstations,
yeah.
Basically our paperwork down the line would have been crazy.
So in some way, the decision that we took in our project helped save us money and also save us maintenance, effort, and time on the long run. So it's something that I want to mention. Any other question? I think we are running out of time.
We're pretty much out of time, but if y'all want to ask questions or something, you can welcome to come up. I want to plug our other presentation, Byron. We manage 128 WISE stations. If you manage any of them, there's a free tool called WDM. He has presentations later in the day, and I believe again on Thursday. That's about it. Thanks for coming.
Thank you.
If you have any questions, you're welcome to come up, or we can stand up here.